Hi everyone, thanks for joining this session. And today I'm super excited to speak about one of the topics that I like most, which is serverless. And we are going to be exploring one specific area, which is security for serverless applications. So, what are the considerations and things we need to know ahead of time when we are architecting serverless applications from the security lenses, right? Okay, when you take a look at this slide, it's really important to understand what are the key areas we are going to be exploring throughout this session, right? And when we consider the best practice uh, from the well-architected framework, there are basically 5 areas for security in the cloud, right? First one is identity and access management. Second is detective controls. We also have infrastructure protection, and we also have data protection and incident response. So these are the key things we need to have in mind when we are designing our applications, right? But it's really important to remember that even though serverless addresses some of the today's biggest security concerns because it removes infrastructure management tasks such as operating system patching and updating binaries. There are still things to be considered, uh, like the way you design your application, right? And even though the attack surface is reduced compared to non-serverless architectures, things like the OWASP and the application security best practices to apply. And in light of this, I wanted to discuss with you some of the best practices to help you address specific ways an attacker could try to gain access or eventually exploit misconfigure permissions. So these are the key things. But before we can drill down to some of these areas, it's really important to remember these 4 things. We need to remember to understand the shared responsibility model. Of course, you guys understand this. Uh, Second, it's really important to remember ways to grant just to work just with the least privilege, and we need to understand ways we can implement defense in depth, considering some of the serverless best practices as well. And last but not least, how we can secure the software supply chain. In other words, your pipeline, right? So the purpose of this conversation is to provide this information regarding the serverless, right? And we are going to apply these 4 principles to a sample architecture, right? So we have a client which is accessing a Amazon API gateway uh, to place on an order. There is the payment service, which is integrated with Amazon SQS. We also have the Amazon event bridge, which is integrating DynamoDB with the loyalty service. And we also have in place an AWS step functions for the fulfillment workflow, right? So we are gonna take a look at these 4 principles and how that can be implemented for this particular application, right? And again, if you have spent much time working with AWS, you are likely to be familiar with this first principle, right? So the shared responsibility model, which is really straightforward, but when we take a look at this from the serverless perspective, from the serverless lenses, you're going to see that this is pretty much for serverful applications, right? On the other side, you're gonna see that with serverless, like with services like Lambda or Fargate, one of the primary benefits is that AWS takes on greater share of this responsibility. But on the other side, this doesn't mean that security is free, right? As shown, customers are still responsible for securing the data, managing their applications and its dependencies, internet access, and so on and so forth. But because AWS takes on infrastructure security, it's easier to maintain the security posture. And just as a reminder, we manage all the things related to operating systems, updates, patching, and monitoring. But I wanted to provide more details on what the infrastructure for serverless looks like to help you understand what are the things you need to be considering, right? When you are designing your application. So remember, once again, we need to take care of the application layer security, authentication and authorization, data encryption, integrity, and also monitoring and logging, or in other words, observability on top of the overall platform. So with this in mind, the first thing we need to consider when designing serverless applications. So rather than just have a huge monolith with hundreds of dependencies, hundreds of resources, and which increase complexity, the way you should be designing our serverless applications is to have these small pieces like a puzzle, right? So we need to put everything together. So we can't assign overly broad permissions. So we are not allowed to, you are not allowed to use create, read, update, and delete when basically just a read or write will do the job. You need to make sure that the access, the data UX is the only thing needed. You don't want to provide more data that is not in the scope of that particular service. And of course, don't include unnecessary dependencies. This is all the rules of thumb for smaller units to make sure your applications just do the job that the service is made for. So this is the first thing we need to be considering. Second, of course, when you take a look at our source code, we need to have a clean code. So rather than have a single function, for example, accessing customer table, order table, and a queue, for sure, this is the way a typical monolithic function would look like. We should design considering the best practices of a RESTful API. So this is the first thing. And then we need to remember that we need to group them based on the type of access, right? So let's say we are talking about an order service. When we need to place an order, there are multiple steps behind the scenes. So we need to group all the functions and functionalities, but based on the type of access. And just as a quick reminder, of course, don't store database usernames and passwords, but instead use managed source like AWS Secrets Manager and to encrypt the environment variables and so on and so forth. Don't have AI identity and access management keys, but instead use STS, assume role, and these are the kind of things you need to have have in mind when you are designing and developing your functions, Lambda functions, right? One additional thing that is really important to understand is that the Lambda service pretty much has two key components, right? The first one is the data plane and the control plane, right? So just as a reminder, the Lambda services is split into these two basic services, right? So each plane basically serves a distinct purpose in the overall service. On the other side, the control plane provides functional management APIs. For example, when you are creating a function, updating function code, and so on and so forth. And it manages the integration with all the AWS services for your Lambda function. On the other side, the data plane basically controls the invoke API that runs Lambda functions. So pretty much when a Lambda function is invoked, the data plane allocates an execution environment to handle that function, or if there is an execution environment already running, it's going to pick up the one that is already set up for that function and then runs the function in that particular environment. So generally speaking, this is the key component. But why this is so important? Because this is the way that we isolate requests within the micro VM and the firecracker, which is the framework used to run the Lambda functions. This is first one of the things that we need to remember, the way things are isolated. Then one important thing when it comes to secure Lambda functions with AWS IAM is that there are basically two types of things we need to have in place. First one is the function policy, right? And then the execution role. So basically, the Lambda function policy allows function invocation. In other words, let's say I have a API gateway A, and then I need to invoke Lambda function B. So this is what a function policy is meant for, to define how the function can be invoked and also support cross-account access. And it's used for both synchronous and asynchronous invocation, right? On the other side, we also have the execution role, which basically is created explicitly as part of the function development and helps to access other AWS resources. In other words, so let's say I want to Lambda function A to call SQS or to write data into a DynamoDB table. So I will be using execution role for this purpose. So generally speaking, the best practice when it comes to this particular area of the secure Lambda functions, we need to basically define a unique policy per function, Lambda function, also to apply to avoid wildcard permissions, and of course always remember to use CloudWatch and Xway if desired, right? So these are the key things. Also, on top of that, it's really important to remember we can also leverage the event bus, right, for to implement event-driven architecture. So let's say we have events defined, and then we have this central event bus, and we need to communicate from a application on account A, and we need to create a new order in a new invoice processing system on account C. So eventually we need to set up this central event bus and use resource policy to define the access we need to use and execution role to be assumed by event bus to determine access to AWS resources. So basically, these are the when it comes to IAM, these are the things we need to have in mind. So execution role, resource policy, and also the function policy, right? So these are the things we need to remember what the purpose and what they are made for. Then the second best practice to grant a least privilege, right? So, and what it means to provide the grant least privilege. So this is really straightforward, but it's really important to make sure you have this when you are designing your serverless application. So basically, you need to grant only the basic privilege needed to perform any specific work, right? And you attach function via AWS IAM execution role. So as mentioned again, just try to have a unique role per function and assign fine-grained permissions and enforce permission boundaries, right? So this is, and one additional thing that could be used, of course, you guys may have came across this, is that you can use conditioning keys with IAM, right? So this is also um, a best practice because uh, you can determine which account or which role or eventually IP address could be accessing that particular function, right? So these are ways you can use to set up the least to grant the least privilege for Lambda functions. And of course, again, as a reminder, try to get rid of the wildcard as much as you can, uh, because otherwise this could result into some unexpected access provided to undesired users or groups or roles, right? To access resource not meant for that particular function. Of course, for those of you that are familiar with Lambda, one of the recommendations of AWS is to use the serverless application model. So, and one thing that is really recommended here is that to use the policy templates, right? And what are the policy templates? Basically, it scopes the permissions of your Lambda functions to the resources that are used by your application. But you don't need to create something from scratch. So let's say you wanted to access, for example, your code pipeline, or you're working with machine learning with Comprehend, or you need to get access to a DynamoDB. So there are basically some out of the box policy templates that streamlines this process. So, for example, you have DynamoDB CRUD policy, which gives create, read, update, and delete permissions to a DynamoDB table. So we have DynamoDB read policy, which gives read-only permission to a specific DynamoDB table, and so on and so forth. So in other words, so rather than just create everything, you can just take advantage of this policy templates to prevent you from starting from scratch, right? So these are the recommendations to automate everything. And of course, AWS serverless application model accelerates this policy and role development because it creates everything for you. And of course, you can configure this when you are working with this particular framework. When it comes to the security principle number 3, practice defense in depth, right? Of course, we want to apply security features that are built into every component of the application. And as a reminder, what are the common vectors of attack? So we have, for example, the application vulnerabilities, application dependencies and hosts and networks. So again, attacks can come from a variety of different places, as you were familiar with. And even though this is not a traditional application, even not being this, serverless applications can things like SQL injection, cross-site scripting, OS top 10, and much more still apply. So using this as a north star for you to remember things you gotta have in place to prevent these issues from happening, right? So these are the things. Dependencies, of course. Sometimes we are working with our creating our serverless applications, and we are leveraging open source libraries, right, to streamline the process. But there are multiple containers, distributions, and libraries used across the board, and sometimes our function is getting bigger and bigger, and the more dependencies we have, the more exposure. So the rule of thumb and the best practice to minimize dependencies, right? So this is the type of thing we need to consider. And of course, network segmentation, the way we are gonna managing our application. So I'm gonna drill down into all of these aspects through the course of through the rest of this session. So again, speaking of securing serverless web services, right? So if serverless architectures are basically loose pieces, we can start to build these pieces together and take advantage of the security features available in each when building our web service, right? So across the service, we have utilized security features available across like web application firewall, API gateway, and so on and so forth. For example, we can leverage web application firewall to mitigate DDoS attacks, right? So cross-site scripting, uh, SQL injection, and OS top 10. Also, on top of that, we can leverage some of the out-of-the-box features included within Amazon API gateway, right? So like the mutual TLS, throttling, rate limiting, authorization, request validation, and so on and so forth. And with Lambda, the same thing. So we can leverage things like minimize dependencies, vulnerability scanning. There are multiple ways to do that and to implement this within your pipeline. And I'll give you a few options while as we speak. Leveraging sanitize input where we are making sure all the variables we are passing to a function they are enforced by some rules and so on and so forth. And same with DynamoDB, right? So how to practice defense in depth, right? So basically the purpose is we need to make sure we're going to apply security at all layers, right? So apply defense in depth approach with multiple security controls. So again, apply to all layers. We also can leverage things like security, the edge of the network. For example, with CloudFront, you can leverage web application firewall and things like that, load balancing, and this type of things, right? So these are the things we should have in place when we are designing our application. So implement multiple redundant measures across systems to address common attack vectors as the one I just mentioned. And also never forget to leverage service features like out-of-the-box encryption with S3, DynamoDB, um, Lambda, and backup as well. So when it comes to the application, of course, one of the key components is the API gateway, which is the front door to API-driven architectures. There are multiple ways and multiple benefits of using this. For example, you can use this to implement throttling, DDoS protection. You may integrate with a web application firewall, implement encryption in transit as required, and also implement multiple and different ways to authenticate using OAuth, or eventually if you need to integrate a third-party identity provider. So there are multiple ways, there are multiple functions that are included out of the box to implement those things. For example, when considering the authorization piece to secure the endpoints, uh, it provides the API gateway supports multiple mechanisms to control access, right? So one of the key capabilities is that the ability to authorize API requests with API gateway and block any unauthorized requests directly at the API gateway layer before any request comes in to your backend integration. So this is one of the key things we can do. Of course, there are multiple ways you can integrate with a variety of identity providers. So you can use the OpenID Connect standard, or use JWT tokens with OAuth, or in case you need to integrate third parties, you can also leverage the Amazon Cognito user pools to integrate with Google, Facebook, and so on and so forth. On top of that, if you wanted to do something more sophisticated and you need more control, you can implement your own Lambda function as an authorizer, which you can use to work with your bearer token and implement any specific authentication authorization procedures and integrate with any specific and internal integrate security system with your company. And of course, you can use the AWS AIM out of the box when you need to provide where there is a mechanism in place using the standard SIG v4, where you pretty much use the keys to sign a request, and then when API gate receives the request, it validates the hash to make sure everything is in place and there is nothing trying to compromise the security of the system. So these are pretty much the things you need to consider when you are designing. And of course, API gateway and the out-of-the-box integration with these identity providers are key to remember. On top of that, it's really important to remember that with API gateway, it supports the MTLS, which is mutual TLS. And basically with that, it helps you to minimize the cost or operational overhead required to manage and scale a traditional reverse proxy fleet for terminating mutual TLS connections. So again, this is something that is out of the box and it can be combined with the previous authorization methods that I just described, like the Lambda authorizers and so on and so forth, right? So this is also the recommendation to be used. One additional thing here to remember, with APIs, there are public and also private APIs, right? So you can have your own VPC, you can have your data centers, direct to connect, VPN or internet, depending on the way you're providing access to. But basically, in order to minimize attack surface area, the recommendation is to present it just with a single endpoint. So this is one of the best practices. So basically, on top of that, you can use resource policies, right? For public to specify AWS account or IP address range, or for private APIs, you can limit the VPC that is accessing that particular private API and use assumed role for this. So this is one of the recommendations. Use resource policies to restrict access in the best way possible according to the application, serverless application requirements. Additionally, it's really important to remember that with API Gateway, there are multiple ways to prevent API backend from being overwhelmed, right? So you can implement rate limiting and throttling in a different way. So you can do that with per client, per method, using the usage plane with the API key inside of the API Gateway. Same thing with per client, right? And per method overall, you can do at the API setting on resource and method. And also on top of that, of course, there is always a way to use source quota to restrict the rate limit. So you can mix and match all of these resources you have out of the box to prevent from DDoS attacks, right? So this is also a good practice to have in mind when you are designing. Again, mitigate DDoS and OS risks, right? So basically, we recommend to use Amazon Cloud from an AWS Shield to defend against DDoS, common transport layers attack, right? And remember to leverage AWS WAF to protect against the common OS top 10 and other vulnerabilities, right? These are the common things we gotta have in place. And again, as a reminder on the things I just said, a brief aside on Firecracker, right? So as a reminder, Firecracker is an open source execution environment customized for running serverless functions, right? And also it's used for AWS Fargate. So it was pretty much created, this was created back in 2017, and it's used in production since 2018, right? And with this, this component allows Lambda to run trillions of invokes per month on Firecracker for the millions of workloads across the board. But why this is important, right? So we need to remember the way Lambda function is isolated. So what the Lambda function isolation looks like. So remember, when we say micro VM, we are speaking about a lightweight virtual machine, and to stand up this environment with micro VM execution environment, Lambda runtime, where the function will be running. There are the workers that stand up all of this environment. Pretty much what happens behind the scenes is that every worker has a maximum lifetime of 14 hours, and basically when this worker approaches the maximum release time, no further invocations are routed to it, and basically these micro VMs are gracefully terminated, and the underlying worker instance is terminated. And when we can basically deep dive on the function isolation by looking at how the Lambda service provisions the environment for your code to run, right? So basically, when a worker needs to create a new execution environment, it's giving time-limited authorization to access a customer function artifact. So remember, these artifacts are specifically optimized for Lambda's execution environment and workers. And this code is uploaded using a zip format and is optimized once, and then is stored in an encrypted format using AWS managed key and some algorithms for this. So basically what happens behind the scenes is each function runs in one or more dedicated execution environments that are used for the lifetime of the function and then destroyed. So basically, in other words, each execution environment hosts one concurrent invocation, but it's reused and in place across multiple serial invocations of the same function, right? So if we have multiple requests at the same time, they are going to be reusing the execution environment rather than just drop the existing one and create something from scratch. This is the way the Lambda function works, but it's really important from the security perspective because you got to be very careful and when storing sensitive data in memory or in a TMP folder, right? Because that could be could be accessed, right? One additional thing that's really important to remember, a micro VM is fully dedicated to a AWS account, but can be reused by execution environments across functions within the same account. And these micro VMs are packed onto an AWS owned and managed hardware platform. And these execution environments are never shared across functions, right? And micro VMs are never shared across AWS accounts. So this is really important to remember because there are multiple layers of isolation. So micro VM, the execution environment, the host itself, the Lambda function, and so on and so forth. So that's why this environment is super secure, right? The fourth security principle that we are going to talk about in this session is basically securing your supply chain or securing your pipeline. This is a particularly important topic given some of the recent events we have seen with some customers where the perpetrator of the breach infiltrated their build pipelines. So we have seen some customers and where they have their own pipelines taken over by hackers and use this to produce malicious software that was exploited. So in other words, so what are the things we gotta have in place to protect the integrity of our pipelines and each component of the application and verifying the downstream dependencies of each application we are deploying. As you guys may remember, there are Lambda functions we can deploy using basically a zip file, or you can use containers, right? So things we gotta remind here. Keep it simple, right? So basically, security is everyone's responsibility. It's not just magic, dust is sprinkled on at the end. So developers need to think about writing secure and clean code. As I mentioned, never hard code secrets in code, leverage code, and vulnerability scanning. There are some out of the boxes and even services that are available at the AWS marketplace that can be used to combine within your code pipeline, for example, to scan your source code, right? And some examples are Sneak, which is a really comprehensive platform for scanning your environment. And one of the things that are really simple and is really great to understand is where your dependencies are, right? So there is this website. So eventually, most of you are familiar with. If not, I would recommend you to give it a try. But basically, it gives you an overall view on the frameworks are using and the dependencies they have in place, right? So basically, your goal to manage a more secure applications to minimize dependencies, of course, and to keep them up to date to reduce risk and effort to protect your application or to protect against data leakage or any type of uh, common attacks. Common security topics. So I just wanted to walk you guys through a few things we gotta have in mind when designing our applications, right? So should my Lambda function be VPC enabled? The answer is depends, right? A Lambda function always runs in a VPC owned by the Lambda service team, right? But when VPC is enabled, you need to uh, configure your access to the VPC via ENI, right? A different thing that you need to consider, right? When you are exposing your Lambda function, you may uh, remember that these VPC enabled Lambda functions are only necessary when accessing VPC resources, right? And remember all the things like VPC routing, NACLs, security groups is still apply for this. So if you have a Lambda function that is accessing, for example, a RDS database with Oracle SQL Server or whatever, you're going to need to set up this VPC enable. And also when you need to access services outside of VPC, of course, you're going to need those private endpoints with private link, for example, using interface endpoints or gateway endpoints when it comes to S3 or DynamoDB, even though that today S3 also supports interface endpoints, right? Second thing, how to improve security at the edge, right? So basically, you can use those servers that I mentioned to add an additional protection layer for the common network layers like layers 3 and 4, networking and transport, layer 7, which is the application, and also on top of that you can combine CDN with some additional security controls leveraging Amazon Cloud Front. So basically you can leverage some of the out-of-the-box AWS WAF rules, or you can create build your custom rules for sure, or you can subscribe to rule groups in AWS Marketplace. There are things built out of the box, right? So you can leverage this service to provide protection with these hundreds of edge locations we have today, just to protect the API gateway. Then it's really important to remember that you need to apply least privilege networking rules to your Lambda functions as well, right? So if you take a look at this diagram, you're going to notice that we have security at the edge with these three key services, right? Protecting the Amazon API gateway, which is the door for the Lambda functions. And in this scenario, we have multiple different Lambda functions accessing a variety of different servers. So we have Aurora with a security group. We have SQS, which is outside of VPC. We have DynamoDB. So we are leveraging gateway VPC endpoint, interface VPC endpoint, and also security group with to access Aurora, which is inside the same, which is in the same VPC. So just a few reminders, right? You can apply your custom routing, NACOs, security group to all of this, right? The similar way as you're doing when you are providing network and setting up your network. Just a few reminders on how to control Lambda function traffic, right? So remember, Lambda security groups do not need inbound rules, right? Again, Lambda functions outbound traffic is managed by security groups, and resources need to allow income traffic from Lambda security groups. And just a few things on top of that, as I just mentioned, the VPC endpoint helps you to enable these private connections to support to those supported servers, right? The private link creates a connection to a service outside of the VPC, and you need to use endpoint policies to control calls to resources outside of the VPC, and you may combine this with resource policies to ensure the use of your VPC. For example, IP address, the VPC that is where the call is coming from, and so on and so forth. So you may combine this into a single place. On top of that, outside of this network thing, how should I handle secrets, right? So this is really straightforward. The recommendation is to, as I mentioned earlier, before, is to previously is to leverage AWS Secrets Manager for protecting your Lambda functions to prevent you from using environment variables, which is available to anyone. So you may leverage this service to keep everything outside of your function, to keep it really simple. And this is the recommendation outside, out of the box. So this is really straightforward, no secret sauce, but this is only a reminder because we have seen, while working with multiple customers, I have seen some of them that sometimes they forget to take advantage of this, and this is a common a common flaw, right? A common deficiency when we see the Lambda functions design, right? One additional thing: how do I know my code has not been changed? This is actually really straightforward and really simple. Basically, as mentioned earlier, use IAM permissions to limit create app update actions. But on top of that, use AWS config and CloudTrail to make sure there's nothing happening behind the scenes. So you may automate with CloudTrail, CloudWatch, and you can trigger some notifications with SNS for sure. And you may leverage code signing to cryptographically sign the code to allow the deployment of functions only from trusted publishers. So these are really straightforward, really simple measures that you may have in place when designing your application. Then, when it comes to working with a Lambda function, we always recommend to leverage Amazon RDS proxy to enforce IAM authentication with your relational database. Of course, there are multiple benefits of this. For sure, it's implementing a database pool connection. But on top of that, you can take advantage of IAM authentication with your database. So you may store the request token with the secrets manager. You may, store your passwords and you can ask for authentication request token. You receive that token, then you connect with the Amazon RDS proxy through the IAM token and validate that token, and the flow goes through, right? This is also a good practice, not only from the high availability and scaling perspective, but also from the security perspective, right? So you are storing your credentials with the secrets manager, and you are passing the token through all these services to connect to the backend database. And also, it's really important to remember that observability is also fundamental and is also instrumental for a successful adoption of security measures. So, what are the ways and things I need to consider to manage logging tracing a serverless application? And of course, you may use monitoring tools like CloudWatch and CloudTrails to identify and report unwanted behavior such as wrong credentials, individuals trying to change the source code, unauthorized access to resources, excessive invocations of functions, unusually long running time. So what is of paramount importance is to ensure sufficient log is enabled for all components in your application. This includes also application level logging. So again, remember uh, to perform regular auditing of configuration using tools like AWS config, and avoid logging sensitive data and debug logging in production. So leverage all of these services together, and you may combine them into a overall solution like the one we discussed earlier, right? So we have security at the edge, we have the API gateway, we are leveraging things like VPC flow logs, Route 53 resolver query logs that we may integrate with CloudWatch for sure. So basically what the data is in the AWS WAF log. So you can use these logs to identify blocked requests generating 403 error messages. You can use this to identify SQL injections and cross-site scripting as well. You can take advantage of these WAF logs and automate integration with Kinesis firewalls, and then use firewalls to publish this into the Amazon Elasticsearch to create a dashboard to monitor all the access through this platform. We have the out-of-the-box integration with VPC flow logs, as I mentioned, and you may also leverage some other platforms like Amazon Guard Duty to provide some intelligence and machine learning to identify uncommon behaviors and continually monitor VPC flow logs and DNS logs in your VPC. So you can take advantage of these solutions and also merge this into Security Hub to provide automated compliance checks integrated with some third-party solutions to protect your overall environment. So just as a wrap up, remember, these are the 4 key principles you gotta have in mind when designing your application. So understand your shared responsibility model, grant least privilege, implement defense in depth, secure your software supply chain. So these are the 4 key measures, and we discussed some of the best practices and ways to tackle and solve these technical and business problems. Well, that's all I had to share. Hopefully you have enjoyed this session and see you in the next one. Thanks for watching. Bye.